In this lesson, we'll explore the ecological case for reusing construction materials, how it saves resources, energy, and emissions. In the ecological context, reuse in construction refers to the reuse of building materials. Its main objectives are conserving natural resources and the energy required to produce new materials, reducing CO2 emissions, other greenhouse gases, and pollutants, decreasing the amount of construction waste. Reuse does not require industrial or technological processing of materials. This distinguishes it from recycling, in which materials are transformed into new raw materials. Reuse fits perfectly into the concept of the circular economy, which aims to extend product lifespans, minimize waste, and make the most efficient use of resources. In construction, this means designing buildings with disassembly and the reuse of components in mind, including the use of secondary materials in new projects. This approach enables a closed-loop life cycle for buildings, offering an alternative to the traditional take, make, dispose model. Building materials are one of the three main input factors in the life cycle of a building. Their rational management, including reuse, can reduce the burden on the natural environment, both at the input to the system and indirectly, at the output from the system. The production of building materials is an environmentally burdensome process, not only due to the exploitation of natural resources, but also because of CO2 emissions, other greenhouse gases, and various pollutants. Reuse of materials means a reduction in the carbon footprint, which in this context is understood as the total sum of greenhouse gas emissions generated during the production of materials, expressed in carbon dioxide equivalent. Reuse of materials also contributes to energy efficiency, specifically through the reduction of embodied energy, which consists of the energy used in production and transportation. This energy balance is approximately 70 to 30%, and in the case of highly processed materials, it can reach as much as 80 to 20%. There are many ways to reuse materials. It all depends on creative imagination. These methods include both structural and cladding materials, elements left in their original location or relocated, components with either preserved or altered functions. Here are some examples. Illustration A shows the recovery of industrial hall beams, reused as the supporting structure of the roof in a revitalized factory, converted into a multifunctional center. Illustration B presents the application of over 100-year-old reclaimed ceramic tiles used to decorate a gateway passage in a revitalized tenement building. Illustration C depicts the reuse of an original steel crane, repurposed as a canopy structure in the adaptation of a former power plant into a multifunctional center. Illustration D shows a reuse of the remnants of the historic Warsaw Ghetto brick wall as part of a modern residential complex façade. The wall bears visible bullet marks from World War II. Together, these examples prove the ecological power of reuse. Next, we'll see how 3D scanning and BIM turn that power into precise, buildable design.